there was a difference. The null hypothesis is there's no difference. The alternate hypothesis is that there is a difference. And then when you report your findings, the APA format requires you to specify degrees of freedom, the t-statistic, and the p-value.
Okay, students, we're back to talk about relationships. This will be our first real discussion of relationships. What is a relationship? A relationship is when one variable can tell you something about the other. So that means if you know the score on one variable, then that gives you a basis to predict something about the other. If that exists, then you have a relationship. If by knowing the score on one variable, it tells you absolutely nothing about the other variable, then you don't have a relationship. So in this exercise, we're going to do an independent samples t-test. And the data set that we use will be directed reading activities, and we have a group who received tutorial treatment, support treatment in the directed reading. And then we have a directed reading project score, a directed reading progress score, that's the DRP. And a t-test measures the difference between two groups. And it so that means that you have two and no more than two groups in a variable that is a nominal variable. So a t-test requires one nominal variable and one continuous variable. So that means that we need to go in here and change this from nominal to continuous. So now we have a dependent variable, that's the variable we want to explain, and the variable that we want to use to try to explain it will be if the student got the treatment or not. Now, this time we're going to go to analysis and T. And you'll notice there are three options. So a t-test can come in three possible types, but there's still never more than two groups. The independent samples t-test is when the scores from the two groups are completely independent of one another. People may not even know each other. The score they get is not going to affect the score that the people in the other treatment get. A parent t-test is different. That means there's a dependence between the first and the second measure. That means that if you have a pre-test and post-test, or you have a matched sample where the people may know each other, husband and wife, that where the score that one person has may affect the score that another person has. And then we have the one sample t-test, and that is where you have your group and you're comparing it to a national average or to a statewide average or international, and that is those are the options that you have. And for us, this example is independent samples. So we have some assumptions that must be met. And one of those assumptions is that you have two groups, no more than two groups. An assumption in statistics is sometimes, that's what they call them, assumptions, but they're really requirements. So you have to have a grouping variable. That's a requirement. And the grouping variable must be nominal. If it's rankable, then you have a different test. So a t-test is where you have two comparison groups, and they are identified by a nominal grouping variable. And then you have a dependent variable, which is continuous. And this continuous variable must be approximately normal. And those are pretty much the assumptions that must be met. I'm going to go through and we'll select the measures that we want. So I'm going to say we want to look at mean differences in our, we'll get a diagram, and then we want to look at the effect size. Sometimes we have a variable or a relationship that is significant, but it may not be meaningful. The effect size may be so small that it is not a meaningful difference. And so we'll take a look at that with 95%. We'll get our descriptives, which tells us the means for the two groups, and we'll get descriptive plots. If we did not have a normal distribution, if it did not meet the assumptions of a normal distribution, then R, there's another measure, homogeneity of variance, and that is in the two groups, you have to have similar variance, homogeneity of variance. You can't have one group with a wide variance and another group with a very narrow variance. The treatment and control group have to have similar variances, and that's what's called homogeneity of variance. Then if it did not meet these assumptions, then we would have to use a non-parametric test like Mann-Whitney. We'll get that no matter what. And then this one is the direction of our hypothesis. Do we want to say, we want to know whether there's a difference, whether it's the treatment group is higher or lower. We want to know whether the difference between the means is significant no matter what the direction. And then we'll in another example, we'll use a directional hypothesis. And you can play around with that on your own if you want. Okay, so meantime, I'm going to, let's take a look at our output. And what you see here is that here is the statistic for the T. And that doesn't mean a lot to us right now, but this one does. And that is telling us that this probability is beyond the 0.05 level. So we have a significant difference between the treatment and control groups. And here are the mean differences. And here is the standard error difference. And then we have the Cohen test. And we have the Cohen is telling us the effect size for both the Mann-Whitney if we don't meet the assumptions of the t-test. And here are lower and upper confidence intervals for the effect size of T. Okay, and so now, here's our normality test. And why does this thing jump back over there? Good. So our normality test tells us that we do meet the assumptions. So here is the Shapiro-Wilks normality test. And that's telling us whether it is sufficiently normally distributed, like a bell. If it's not, then t-tests don't work very well. If that is significant, then we didn't meet it. So it's the opposite of the other significant test. We want the other to be beyond 0.05, smaller than 0.05. But we don't want this number to be smaller than 0.05, because then it's telling us that it's significantly different than a normal distribution. And here's the homogeneity of variance, and it is also not smaller than 0.05, which we also want. We don't want these to be significant. We usually want this one to be significant, but not these two, because that means we didn't meet the assumptions. So that means we don't have to use Mann-Whitney if we don't really want to. And here are our means for the control and the treatment. So the treatment group got a score on that progress test of 51, and the control group 41. So that means that there is a difference. And here is a measure of the shape the compliance to normality, and you can see that these dots are pretty close to being on the line. So anyway, this is an example for you to work through, and then you answer the questions. If you have any other questions about using the program, don't hesitate to call.
Okay, let's do a quick review. There were three types of t-tests, and Jamovi and all statistical packages offer the independent samples t-test, the paired t-test, and the one samples t-test. And we've discussed how those fit. And there are certain assumptions to the independent samples t-test that covers what we did in this video. And that is, we need a nominal independent variable with two categories. Only two, T for two. If it's more than two, you have to go ANOVA, and we'll talk about that in another video. The dependent variable, which is continuous, has to be approximately normal. And we need to be able to calculate the mean, so it has to be continuous, and it has to be approximately normal, and we need to have homogeneity of variance. If we have two groups, the groups have to have similar dispersion. They have to have a similar amount of variance. The standard deviation has to be within a certain range, and there are tests that we looked at to determine that. And the hypothesis, the null hypothesis is always that there's no difference between the two groups. The alternate hypothesis is that one group is different than the other. Here are a couple of real-world examples if you wanted to compare peer tutoring to faculty tutoring to see which of the students had greater student success. Then we could do that. We could have two groups, one of people who had a SAT prep compared to students who didn't, and didn't make a difference in their grades. And then we could also look at starting salaries for men and women at a certain ABC corporation to see whether or not